With respect to the query processor, with respect to the parser, whenever any query is going to come up, so it's a responsibility of parser to cross check the template of the query, whether the query is up to the mark or not, and then after cross checking it, hand over the same to the optimizer. If you remember, the job of optimizer is to prepare the query plan. This is the one which tells that what is the execution plan which the query has to follow. From the optimizer, the query goes to the SQL manager, which takes care of it, that how the query is going to be worked upon, and then it gets handed over to the database manager, because database manager has to cross check if at all the query is going to be there a load for the server, what is the priority, from whom the query is coming, whether the query should go in a query in the queue or not, or the query should be processed on the priority basis, and accordingly it gets moved on to the query executor. Now this is the processes which are related to the query process, which are related to the queries. If we have a look at the storage engine, these are the activities which happens at the storage engine. We have transaction services, we have file manager, which are associated with different utilities, and we also have buffer manager and lock manager, which can be accessed with the help of different methods. For example, for rows, index, versions, pages, or allocation, it can be accessed with the help of the buffer manager. And then the locking manager is the one which helps us to have a lock on rows, lock on pages, lock on tables, etc. These utilities like bulk load or DBCC, the DBCC couple of commands we did yesterday also. The DBCC backup or restore, these are the ones which are your transactional services. We have different file manager also which works for it. And then we also have the SQL OS. So this is the SQL OS API, where we have a lock manager, memory manager, synchronization services, thread scheduler, IO manager, buffer pool. These are the things, these are the different processes which we have. And the worker threads which are associated are deadlock monitor, resource monitor, lazy writer, schedule monitor. These are the ones which work parallelly with all these processes. We also have external components which host your API, like CLR and MDAC. So if at all we have a look, all these components combined together, then only an instance is formed. Then only the query gets passed on from the user to the database, and from the database, this is how the query is handled. Now over here is a very short and simple way to understand the query movement in an instance. Now over here, let's say that this is your client who is going to pass on the query. The query from the client is going to come over here to the protocol layer, which is responsible to cross check the protocol. From the protocol layer, it goes with the help of the different languages. As you are aware of it, SQL Server works primarily with SQL, that is structured query language, but it can also work with XML, and we also have .NET support in SQL. So depending upon the different language, the language events are picked up, and then it is handed over to the command parser. Now the command parser prepares the query tree. This query tree is the same which you are able to see when you work with the execution plan. If you remember, we worked with the estimated execution plan. So your parser prepares the query tree. So the command parser hands over the query tree to the optimizer. Optimizer is the one which takes care of this execution plan, and optimizer's basic job is to have the execution plan ready and then pick up the best execution plan. From the optimizer, this particular query plan is handed over to the query executor. From here, query executor, the plan can go back to the protocol layer if at all we are not having that appropriate table or the appropriate object associated with the query. In case the table or the object is there, then this query executor passes on to the different query executor passes on further ahead, and then appropriately different access methods are used to cross check how to access the query. From here the query moves ahead and goes to the transactional manager. Now let's assume that the kind of query which we have got is a select query. So in that particular case, the access method for a select query is directly reach out for the database file without disturbing the log file or without disturbing anything else in the database. So at that point of time, the access method will come over here and it will post the query in the buffer manager, and as we are aware of it that already your optimizer has given out the query execution plan. Now as soon as the plan is given out, along with that the various other information regarding the query, the size of the table, if at all the table is, if at all the results are going to come to the instance, then how much size the instance requires, what is the size which I need, what is the amount of memory which has to be reserved over here in your buffer manager to keep control of it, and for easy movement of data to and fro from your data file to the client. Now once your select statement reserves the memory, once your select statement searches the buffer manager, if the memory is available, perfectly fine. If memory is not available, as we are aware of it, there are two different areas of buffer manager. The first area is called as most recently used or MRU, and the second area is called as LRU or least recently used. Buffer manager first of all searches for the space in MRU. If in the MRU the space is not found, then it moves to the LRU. From the LRU, if any object which has got expired can be moved out of the instance, it will be moved out, and the appropriately objects will be pushed down to LRU, and there will be a space which will be made in MRU. Now this query, select query, which will go as a query which is be treated as the topmost query in the MRU. Now from here, when the query has already just reserved the space, which does not mean having a lock, there is no locking, it is just that we have reserved the space. We have specified over here, the query specifies over here that this much of space is what I require. Now from the buffer manager, as you are able to see, it moves, the query moves to the data file. In the data file, as per the execution plan, the query knows the address of the table, and it also knows the access method to access the table. If at all the access method is to reach out for the index and then finally go ahead for the table, so it first of all locates the index, picks up the data from the index, and then finally reaches out for the table, and then the table is moved from the data file to the buffer manager. From the buffer manager, now the data is moved to the data cache where the memory been reserved. From the data cache, the data is finally handed over back to your client. With respect to this data cache which has been given over here, the data, once the data gets placed in the data cache, which actually is a part of this, it's a part of your buffer manager. The data goes back to the access methods, goes back to the query executor, goes back to the protocol layer, and finally it is handed over back to the client. This is how it goes on. If at all the query which has been posted by the user is an update query or any delete or any insert, so in that particular case, initially the query will go through all the complete path over here, whatever been given, just like a select statement, with the difference that the query optimizer will opt for telling the query that this is the size of the row and this is the size of the row this is the space which will be required to place the query. Now once the data is available from the optimizer, it comes to the access methods. Now for the same query, a copy of the query goes to your buffer manager and it resides in the data cache where it locks the pages, and along with that the query comes to the access method. The query comes over here from the buffer manager, moves to the data file, it picks up the old data, because let's suppose if we have got any update clause. So update clause which is holding the new data. So I need to get the old data. So my old data is still residing in my data file. In the data file, from the data file, the old data will be picked up. It will be transferred to the buffer manager. Now in the buffer manager, I have got the old data as well as the new data in the locked state. Now when the data is locked, a copy of data will be moved from buffer manager to access methods to the transaction manager. As soon as the copy of data is moved to the transaction manager, immediately it is signaled to the transactional log to start writing down the data which has come over here. Now as soon as the data gets written into the transactional log, that point of time it will be signaled that the synchronization has got completed for my physical database as well as my logical database. If you remember, it was mentioned that it is the duty of a checkpoint process to look after the synchronization of the database. Now synchronization of the database means the synchronization of my instance, which is my RAM, which means the data existing in the RAM, and the synchronization of the data which is existing in my hard disk in the form of transactional log and in the form of data files. So this is how the data movement happens in case of instance. Learning the instance, understanding the instance is extremely important for us to work with the queries. If at all your queries are not tuned nicely, optimizer will give misleading query plans, and your buffer manager will opt for working on those query plans, and it will opt for occupying the different amount of memory in the data cache, and appropriately a wrong signal will be sent to the data file. Wrong signal in terms of different space utilizations. So this is with respect to the instance. The next thing we have is query performance tuning.